In this video, I will show how to write a function with Python and R. For the example, I will create a function that accepts a numeric input given by an argument x, and then the function will tell us if the number x is prime or not. And to do this, I will use a special division given by the percentage symbol. And this is different than the common division, because if we use the common division, it gives us the classic division that we know. But if we use the percentage symbol instead of the slash, that gives a result of 0, because it gives a value of 0 if the number of decimals in the operation is 0, and otherwise it gives a value of 1. Here I define a function that's not correct, and we will use this as a starting point, and then we will debug this function to create a correct function. I am using the def statement, that's to create a function, and then I create a new function called isPrime, where the argument is x, and that's any input that then I can give to my function. So inside the function, I start by creating an empty list, and I will fill this list with a sequence of numbers from 2 to 1 digit before x, and this is because of Python's zero indexation. So here for each of these numbers, let's say that our input is x equals 5. The range function will return 2, 3, and 4 in this case, and each of these elements 2, 3, and 4 will be appended to the list y. Then, with a for loop, I will conduct an integer division where for each element I in the list y, I will take the input x of the function and conduct an integer division, and if the result of this operation is 0, I will print x is not prime, because that means that we found an integer divisor of x, and in other case I will print x is prime. But this function has a problem, and we need to explore which is the actual problem. So I will run the cell now to have the function in memory. And now I will test different values as inputs. So I will run if number 3 is prime, and the function tells me x is prime. Then I test if 4 is prime, and it tells me x is not prime, which is correct, same as the previous case. But now if we test, let's say 21, that's at 3 times 7, it tells us 2 mutually incompatible statements. This function told us that 21 is and is not prime at the same time. So we need to correct our function. So now we debug the function, and here I write a manual input. I put x equals 21, and then I move some elements that I wrote inside my function out of the function. So I start with an empty list y, then I use a loop, a for loop, to create a sequence of all the numbers from 2 to 20 in this case, because x is 21. I append those numbers to my list y, and then with another for loop, I print each of the values that I will be using to divide x, and I repeat the same operation if x divided by I in this special way is 0, that means that the division contains 0 decimals, then I print that x is not prime, and in other case, if the result of the special division is 1, then I print that x is prime. And for this operation here, those are the only two options, that the result of this division is either 0 or 1, with no other possibility. So if we conduct this, we will see what happens for I equals 2, 3, 4, 5, etc. And here we have different statements. So these statements are mutually incompatible because we are telling that x is prime and not prime, depending on the value that we test for the division. So then we need to move the print outside the loop. That's the lesson from this. So now I will create another function, and here I did a copy and paste of the previous function with some changes. I start by creating an empty list, and then I append the sequence of numbers once again. But now here I included something new. I create an index. In this case, the index is p, and I start with a value of p equals 0. And then if p is greater than 0, that will mean that x is prime. So how do I update this value of p equals 0? Then I use another for loop, and for each element I in the list y, I conduct the same special division, and if for any of those numbers the result of the special division contains 0 decimals, then I update the value of p, and I do that with the plus equal, which means to add something to a previously existing value. So here I'm adding 1 to my previous value, which is 0. And inside the loop, and also inside the if, the tabulations here are really important. If I move the break to the left, that won't work. Then the break here stops the iteration. So once I have found a number that is an integer divisor of x, then the operation stops there, and I don't test with the rest of the numbers in the sequence if there are more numbers to test. For example, if I'm testing for 21, same as the previous case, when I test for x equals 21 and I equals 3, then the condition x divided in this special way by I is equivalent to 0. And then I don't need to test for I equals 4, 5, 6, etc. up to 20. And then with an if-else, if p is greater than 0, I print that x is not prime. And in other case, I print that x is prime. So now I test my function again. So I will test the previous cases as well. So according to this new function, x is prime. In this case, x equals 3 is prime, correct. Then I test for x equals 4. It's not prime, correct. Then I test x equals 10, also not prime, correct. And now I test the conflicting case, 21. And what happened here is that I forgot something really important, that I need to run my cell and test again. This is common, so now we test once again. So I test again. Is prime? and I give a value of 3 as input, and it tells me that x is prime. Good. Then I test 4 and tells me x is not prime. Correct. Now I test 10 and it tells me x is not prime. Correct again. And now I test the problematic case once again, 21. And now it tells me x is not prime, which is correct. Now I will do the same with R. The syntax, the way you write it's a bit different. So I define a new function, is prime. The arrow is to create an object in R. And here I write function of x. It's a different notation, but it's the same logic. And the difference is that instead of creating an empty list and then appending in R, I can create a sequence from 2 to x minus 1. That's perfect. Then I create my value p as an index. And then inside my for loop, I overwrite my p value by writing p equals p plus 1. That's p equals p. And then I add 1 to the already existing value of p. And then I break the statement if I find an integer divisor of x. And then the rest of the function is the same. I print messages depending on the value of p. So I will run this add function now. Now I have the function in memory. And now I test the value of 21 and it tells me that x is not prime. Some of you have asked me about ChatGPT and Copilot and all of that, and I will show you that those are useful to provide some skeletons that we can use for our functions, but we need to be very careful with what we have in there and how we use that. For example, if in Python we type a comment here like write a function to test if a number is prime, we can pass that and it will suggest a certain function, and now I will activate Copilot and it should suggest a function. So I will type def is prime, and after thinking that's suggesting a function, right? So that basically use the function that I defined previously. Okay, so after we gave this a few seconds to think, this gave us something that's correct now, but what if we create a new notebook and we don't give previous information to this? So I will save my changes and I will create a new file. So we'll create a new Python notebook. Here I will use my default Python environment, and here I will write a function to test if a number is prime. Right? And this is all auto-completion. Okay, and that's it. So in this case, it's suggesting something more compact, right? But the idea is that you should be able to read this and understand each of the lines in the function, right? Because there's more than one way to test if a number is prime or not. So try to use this, but be careful, because one of the suggestions that I saw previously is that the auto-completed function was just doing the special division by 2 and testing just dividing by 2. And in that case, for example, 15 will be a prime number if I just test dividing by 2, because I haven't tested if 15 is divisible by 3, or 5. So please be careful, use ChatGPT, use Copilot, and try to read what you